Again, I will repeat. Today test portion, chapter number 14, semiconductor. You can prepare all the topics. It is very important. You can score good mark for in this chapter. Okay. So now we are discussing atom in this chapter. The basic structure of atom, Rutherford alpha particle scattering experiment, J. Thomson model of experiment. Next, that Bohr'S series, atomic spectra. So everything we discussed, ma. Now we can go for the visual. Some other things also there. Kindly watch the video. If you have any doubt, we can ask through the chat box. Listen properly. Already I said, listening is the beginning of prayer. So listen properly. After we can copy the notes.
Now, let us look at the H-alpha line of the Bohr'S series. Bohr gave a simple empirical formula which these wavelengths follow. If the wavelength of the spectral line emitted is lambda, then 1 by lambda is equal to r into 1 by 2 square minus 1 by n square, where r stands for Rydberg constant, which is equal to 1.097 into 10 power 7 per meter, and n takes integral values 3, 4.
Okay, please note the value of Rydberg constant. The capital R value 1.097 into 10 power 7 meter inverse. So this is a value of Rydberg constant. The capital R. And we know very well Bohr'S series, Lyman, Paschen, P found bracket, and all the things values. Again, it is a small example.
5, and so on, up to infinity. This equation is called the Bohr formula. Let this be equation 1.
Bohr's second, n1 value 2, n2 value up to infinity, 3, 4, 5, up to infinity.
Bohr's series can also be written in terms of frequency, nu. We know that velocity of light c is equal to nu lambda. That implies 1 by lambda is equal to nu by c. Substituting this value of 1 by lambda in equation 1, we get nu is equal to rc into 1 by 2 square minus 1 by n square. Substituting n equal to 3 in equation 1, we get 1 by lambda is equal to 1.097 into 10 raised to the power 7 into 1.
So this is related to frequency, ma. Frequency formula it is related to frequency. 1 by lambda is equivalent to the nu by c. That is not a v. It is a nu. Nu means frequency. The symbol of frequency is nu.
By 2 square minus 1 by 3 square. This is equal to 1.52.
And applying for R value, Rydberg constant, and C value. C means speed of light in vacuum. So all the values you can apply, and we should take that n2 value also 3 for our assumption. First we consider
2 into 10 raised to the power 6. Thus, lambda is equal to 6563 angstrom or 656.3 nanometer. This is the wavelength of the H-alpha line of the Bohr'S series.
So Bohr'S series wavelength 6563 Armstrong for the first level. N3, N2 value is 3. For lambda means wavelength. Armstrong value 10 power minus 10 meter. N, it is nano. Nano value 10 power minus 9 meter. Armstrong, a power 0 means Armstrong. The value is 10 power minus 10 meter. Nano, n, that is the n is a nano. The value of nano 10 power minus 9. Please note the values, ma. Lambda value alone. If you don't take your NCERT book in physics class time in your hand, physics book, physics classwork, and a writing pen, pencil, everything should be there. Bohr'S series lambda value wavelength 6563 Armstrong. It is constant while applying for N2 values 3. My voice is audible. It is clear to you.
Yes, sir.
Yes, sir.
Okay. If you have any trouble, you can inform.
Is in the red of the visible region.
The region, Bohr'S series region is visible region.
For the next line of the series, the H beta line, we have n equal to 4, and for n equal to 5, we obtain the H gamma line of the series. By putting n equal to infinity, we obtain the limiting wavelength of the series, which is equal to 3646 angstrom or 364.6 nanometer. The limiting wavelength is the shortest wavelength of the series. Now let us look at the Lyman series, which has wavelengths in the ultraviolet region of the spectrum. The
But this lambda is shortest range.
presence of ultraviolet wavelengths can be detected by a silver chloride soaked paper, which turns black when exposed to them. The empirical formula for the Lyman series is 1 by lambda is equal to R into 1 by 1 square minus 1 by n square. Here, n is equal to 2, 3, 4, and so on, up to infinity. Let this be equation number 2. Now let us look at the Paschen series. The Paschen series has spectral lines which lie in the infrared region.
Very particular which region it is belong to. Paschen series, it is belong to infrared region. That is very important key point. Please note it. Audio is said, kindly note properly. Take a notes.
The formula for the Paschen series is 1 by lambda is equal to R into 1 by 3 square minus 1 by n square. Here, n is equal to 4, 5, 6, and so on, up to infinity. Let this be equation 3. The bracket series has spectral lines which lie in infrared region. The formula for the bracket series is 1 by lambda is equal to R into 1 by 4 square minus 1 by n square. Here, n is equal to 5, 6, 7, and so on, up to infinity. Let this be equation 4. The Fun series has spectral lines which lie in infrared region. The formula for the Fun series is 1 by lambda is equal to R into 1 by 5 square minus 1 by n square. Here, n is equal to 6, 7, 8, and so on, up to infinity. Let this be equation 5. Spectra of only few elements like hydrogen, singly ionized helium, doubly ionized lithium, etc. can be represented by the simple formulae like equation 1, 2, 3, 4, and 5. Still, these equations are very important as they give the wavelengths that a hydrogen atom radiates or absorbs. When white light passes through a gas and the transmitted light is analyzed, we get a spectrum called absorption spectrum. The absorption spectrum consists of dark lines corresponding to the wavelengths which were formed in the emission spectrum of the same gas. An element can absorb those wavelengths which it can emit. The absorption spectra of elements consists of dark lines against a bright background. Rutherford's nuclear model of the atom postulates that electrons revolve around the nucleus, which contains the total positive charge of the atom. However, it could not explain certain other facts. Let us now look into the drawbacks of Rutherford's atomic model. It assumes that the system of electrons revolving around the nucleus is similar to that of our planetary system. As the gravitational force holds the planetary system together, the electrons around the nucleus are held by electrostatic force in an atom, which is given by Coulomb's law. The electrostatic force between the electron and the nucleus acts as the centripetal force on the electron, because of which the electron gains centripetal acceleration. According to the classical electromagnetic theory, an accelerated electron should continuously lose energy as it emits radiation in the form of electromagnetic waves. As a result, the electron would spiral inward and eventually fall into the nucleus, and thus make the atom unstable. Also, the classical electromagnetic theory states that the frequency of electromagnetic waves emitted by the revolving
Last class we discussed on one more question. The atoms are stable, unstable, electrically stable. So now you can get better idea whether it is stable or unstable or electrically stable. It is electrically stable. And this is the drawback of Rutherford model of the atom. Whenever you study any experimental studies, you should remember the drawbacks and the conclusion, observation, diagram, observation, conclusion, drawbacks. So each point one mark it is. So this is the drawback of Rutherford model of the atom.
electrons is equal to the frequency of its revolution. As an electron spirals inward, its angular velocity and frequency changes continuously, which consequently changes the frequency of the emitted radiation to form continuous spectra. But experimentally, a line spectrum is observed. The hydrogen spectrum is an experimental evidence for the above analysis. So it is clear that the classical electromagnetic theory and Rutherford's atomic model were inadequate to explain the atomic structure. In order to overcome these limitations,
okay, next one, the Bohr model of hydrogen atom. Please listen properly.
in 1913, Niels Bohr gave his postulates based on quantum theory of
What is postulate? Anybody remember postulate? Take a dictionary and find the meaning. Postulate.
radiation. Key combine.
Find the answer. Postulate.
Sir, what, sir?
Postulate. Yeah, very good. Priyanka, Mukesh, Kumar, Abarna. Yeah, it is our assumption. We should take like this, it is there. It is not proof, but we consider like that. Okay, listen properly. Related things we'll discuss one by one. So it is important 5-mark question. Bohr model of hydrogen atom. The Bohr conclude that the classical concept, another one quantum concept. Classical concept means like a micro scale level. Quantum means before. You know very well that Pauli's exclusive principle. In chemistry, you learn no Pauli's exclusive principle. Each cell contains 2 electrons. The 2 electrons also in opposite spin. At 1s2, 2s2, 2p6, the cells electronic configuration and all. This is all related to the quantum level. Okay, classical and quantum concept combined together, explained by the Niels Bohr. That is the Niels Bohr's postulates. There is 2 postulates. Based on that, we'll discuss. Listen properly. After you can take the notes. First, listen.
Combined the concepts of the classical and quantum theories to form the basis of his 3 postulates of an atomic model. According to the first postulate, an electron in an atom could revolve in certain stable orbits without losing energy continuously. This means each atom exists in a definite stable state, and each existing state has a definite total energy. These are called the stationary states of the atom.
What do you understand? First one. Again, you should remember that energy level KLMN. The value of K, it is equal to 2. The 2n square formula. Value of L, it is equal to 8. So it is constant only, no. So each atom exits in the definitely stable state. Each exiting state has a definitely total energy. The stationary state of the atom. This is the reason the atom is a stationary. Before that, Rutherford said it is a stationary, but he didn't explain about the energy and the stable condition, why it is stable, how it is stable. But after Bohr's, he will explain properly for the conditions. Each atom exits in the definitely stable state, and each exiting stable has a definitely total energy. So this is the reason. K cell means that is a value. S means that is a value. It is a constant. We cannot change. Did you understand first one? Shall we go for next?
Yes, sir.
Okay.
His 3 postulates of an atomic model. According to the first postulate, an electron in an atom could revolve in certain stable orbits without losing energy continuously. This means
it is not losing energy continuously. Remember.
Each atom exists in a definite stable state, and each existing state has a definite total energy. These are called the stationary states of the atom. Therefore, as long as the electron occupies these stable states, there is no loss of energy in the electron. According to Bohr's second postulate, the electron revolves around the nucleus only in those orbits for which the angular momentum L is an integral multiple of a constant equal to nh by 2 pi, where h is Planck's constant equal to 6.625 into 10 to the power minus 34 joule second. Therefore, the angular momentum L of the electron is equal to mvr, which is equal to nh by 2 pi, where m is the mass of the electron, v is its velocity, r is the radius of its revolving orbit.
Okay, listen. The second postulate based on the formula. It is related to angular momentum. The angular momentum L. Normal momentum P. P is equal to mv. But angular momentum L. Omega R. In class 11th, system of particle and rotational motion. In this time you studied. So angular momentum capital L, it is equal to nh divided by 2 pi. nh equal to nh divided by 2 pi. It is a proof. Okay. Now what is h? H value is the Planck constant. The value is 6.625 into 10 power minus 34 joule seconds. Next one, the angular momentum, the abbreviation mvr. Omega or mvr. This is the relationship between the angular momentum and the linear momentum. V is the velocity, m is the mass, and r is the radius of the orbit. Again, listen properly. L, that is the angular momentum. V is the linear momentum. So the relationship between angular momentum and linear momentum, L equal to mvr. So r is the radius of the orbit, m is the mass of the electron. Clear? Okay, listen. After you can take a notes. First, everyone listen. That is the second postulate formula. L is equal to nh by 2 pi. That L formula mvr. Up to that, remember.
And n is an integer. Let this be equation 1. According to Bohr's third postulate, an electron might make a transition from one specific non-radiating orbit to another of lower energy. When it does so, a photon is emitted having energy equal to that of the energy difference between the initial and final states. The frequency nu of the emitted photon is given by the relation h nu is equal to EI minus EF. Here, EI is the initial state energy and EF is the final state energy of the electron. Let this be equation 2. Let us now derive the expression for the radius and energy of the hydrogen atom.
Okay, listen.
Relation.
There is no explanation about energy of the photon. Now, Bohr model of the hydrogen atom, we can get one relation, that is the energy related. The proton means h nu. H nu is the photon. It is equal to the difference of energy.
H nu.
What is the difference of energy?
Is equal to EI minus.
1 second. The difference EI minus EF. EI means that is the initial energy minus final energy. The photon value is equal to the energy difference. Energy difference means initial state minus final state. That is jumping energy. Okay, next we will discuss the expression for the radius and the energy of the hydrogen atom. Expression for the radius and the energy of the hydrogen atom. Expression means in mathematical terms.
We can write mVnRn is equal to nh by 2 pi. Here, n is an integer, Rn is the radius of nth possible orbit, and Vn is the velocity of the electron in the nth orbit. Let this be equation 3. The allowed orbits are numbered 1, 2, 3, and so on, according to the values of n, which is called the principal quantum number of the orbit. We have learned that the relation between the radius r of the electron orbit and its corresponding velocity v is given by Rn is equal to e square by 4 pi epsilon naught mvn square. Let this be equation 4. Substituting the value of Rn in equation 3 and simplifying, we have Vn is equal to e square by 2 epsilon naught nh. Let this be equation 5. Substituting equation 5 in 3 and simplifying, we get Rn is equal to epsilon naught n square h square by pi me square. Let this be equation 6. By substituting n equal to 1 in the above equation, we get the radius of the innermost orbit, which is Bohr's orbit and is represented by A0. Given A0 is equal to epsilon naught h square by pi me square. Substituting the value of Planck's constant h, epsilon naught, and the magnitude of the charge of the electron E, and simplifying, we get A0 is equal to 0.529 into 10 to the power minus 10 meter, which is equal to 0.529 angstrom. From equation 6, it is clear that the radii of orbits are directly proportional to n square. According to Rutherford's model of the atom, the energy En of an electron for a particular orbit of radius Rn is equal to minus e square by 8 pi epsilon naught Rn, where n is the principal quantum number. Let this be equation 7. Substituting the value of Rn and simplifying, we get En is equal to minus me to the power 4 by 8n square h square.
For derivation part I will explain. Okay, first listen. Again I will explain derivation part. Okay. Few students asking doubt. I will explain. First listen the concept.
Epsilon naught square. Let this be equation 8. Substituting the values of m, e, epsilon naught, h, and simplifying, we get En is equal to minus 13.6 by n square electron volt. Let this be equation 9. The negative sign of the total energy of an electron moving in an orbit means that the electron is bound with the nucleus. Substituting n equal to 1 in equation 9, we get the energy of the first orbit, E1, is equal to minus 13.6 electron volts. This is the lowest energy state of the atom and is called the ground state. Thus, the minimum energy required to remove the electron from the ground state is 13.6 electron volts. This is called the ionization energy of hydrogen atom.
Okay, listen. For this purpose, that is the E1, that is ground level, we should exit one single atom, means we should apply for the 13.6 electric volt. Then only it will exit one level to another level, ground level to first level. In this derivation part, I will teach you. Okay. First, you want to understand what is the Bohr model of hydrogen atom. It is very important. Bohr model of hydrogen atom. There is a three postulate. The first one, it is related to stable condition, the stationary state of the atom. Each atom exit in the definitely stable state. Each exiting state has a definitely total energy. So related to stationary state of the atom. Why it is stationary? Second postulate, it is related to angular momentum. L equal to NH divided by 2 pi. Under that L formula is rewrite MVR equal to NH by 2 pi. This is the second formula, second postulate. After that, the expression for the radius and the energy of the hydrogen atom. Radius as well as energy. So radius means R formula. That R formula only Rn equal to epsilon n square h square divided by pi me square. For the Bohr orbit, we consider that R is the first orbit. So then applying the values, you will get values that Rn is directly proportional to the square of the n. The radius of the orbit is directly proportional to square of the n. This is a 1 mark question. Please remember. Next, related to energy formula, the energy En equal to minus E square divided by 8 pi epsilon naught Rn. Then applying the values, you will get final equation En equal to minus 13.6 divided by n square EV. N value 1 means this is the lower state value. Okay, then based on the n value, it is different. N value 2, n value 3, up to infinity. Maybe they will tell you the n value is 5. We can apply for 5 and find the answer of En.
So, to excite an hydrogen atom from ground state, where n is equal to 1, to the first excited state, where n is equal to 2, the energy required is E2 minus E1. This is equal to minus 3.4 minus 13.6, which is equal to 10.2 electron volts. Similarly, to excite an hydrogen atom from the ground state, where n is equal to 1, to its second excited state, where n is equal to 3, the energy required is E3 minus E1. This is equal to minus 1.51 minus 13.6, which is equal to 12.09 electron volts. When the electron falls from the excited state to its ground state, it emits a photon whose energy is equal to the energy difference between the excited state and the ground state. For example, if the electron comes to its ground state from the first excited state, the energy difference will be E2 minus E1 equal to 10.2 electron volts. And thus, a photon of energy 10.2 electron volts will be emitted.
Okay, remainder things we'll discuss, ma. 1 second. So today we are discussing one second, it is not moving. This one, the energy levels, ground level, N1, N2, N3. Next, so based on drawback, this one, okay. The derivation part we will discuss next. Niels Bohr's 1885, 1962. This track only we will discuss today, ma. Bohr's pass rate, first pass rate, second pass rate completed. Third one, it is related to radius, that h nu is called EI minus EF formula. Third one,